Hey IPS, sorry I can't be with you today. I'm over at Prairie Knolls attending a workshop, so hope you all did well on your quizzes and you all remembered your units. So you want to open your lab notebooks up to your table of content. This will be number 4 and it's going to be significant digit notes. Why don't you pause me now to make this entry and turn in your lab notebook to where you will be taking these notes. So, why do we have significant digits? Not every instrument has the same precision. So if you're using multiple instruments, let's say you're using the 50 milliliter grad and you're also using a ruler. Well, 50 milliliter grad has 1 decimal place, a ruler has 2 decimal places, so they have different precision. So if we're using these multiple instruments, it's going to affect the accuracy of the answer that you report. In recording our lab data, we need to take into account significant digits, and you're going to be doing this in an upcoming lab. So we're going to look at today then how we determine whether numbers are, and we're going to look at how we then use those numbers when we are doing our calculations. Let's look at first determining the number of significant digits. Basically any non-zero number. So any number between 1 and 9 is going to be significant. So every number but 0 is always significant. You have to actually measure these numbers to put them down. You have to look at them and make that measurement. So all of those numbers are significant. So that leaves us then with zeros. So what do we do about zeros? Well, sometimes they are and sometimes they're not. And this is the confusing part about significant digits, is what to do with these pesky zeros. So let's say 0 happens at the beginning of a number, or it starts the number. For example, 0.0002. The zeros are all at the beginning of the number, or they start the number. These zeros would never be significant. All they are doing is holding a place, they're holding the 2, but have no significance otherwise to that number. So zeros at the beginning, never. So zeros that happen to be sandwiched in a number. For example, 10.0002. 405, 1010101. Sounds like a school chant or something. These zeros are always significant, and that is because they are sandwiched. We were able to record 1 and we were able to record 2. We were actually able to measure those numbers. So everything in the middle had to be measurable also. So those are all zeros. Anything that's sandwiched in the middle is significant. Doesn't matter how many zeros are in the middle, as long as a number starts and a number ends, then you have significant zeros. So zeros that are in the middle are significant. How about zeros at the end of the number? Any guesses? Well, I guess whatever you guess would be right, because it depends on the decimal place. We like to say a little thing, the dot means a lot. Without a decimal place, we are never significant. In 120, there is no decimal place, so this 0 is basically not significant. In 54,300, these zeros are basically not significant. Do you need to write them? Of course. If you don't write them, it changes the whole value of the number. But they are not significant when we work with them later on. So you need to write them. They need to hold that number in place, but they are not significant. However, zeros at the end of the number that have a decimal place. Remember that dot means a lot? Let's hear everybody. Dot means a lot. Dot means a lot. All of those zeros are going to be significant. Doesn't matter if they're at the end. If there is a decimal point somewhere in that number, the zeros at the end of a number are significant. Let's look at some practice. We've got 2,349, and we want to know how many significant digits are in that number. Well, if you look at it, I don't see any zeros. Since there's no zeros, all of these numbers are, and this has 4 significant digits. Let's look at the second number. Ooh, we have some zeros. Well, we know 9 is going to be significant and 3 is going to be significant because they are not zeros. These zeros are in the beginning. And if we go back and look at our notes, zeros that are in the beginning or zeros that start a number are not significant. We need to have them there. They need to hold the 9 in its spot, but but when we count numbers, we're going to say this one only has 2 significant digits. In the third one, we have some zeros again. Well, we know 1, 2, and 9 are significant, but these zeros, I don't know, they're at the end. So they can go either way. So what are we looking for? You got it. We're looking for that dot. The dot means a lot. The dot means a lot. So let's look at this number. We have a dot here. So we have our decimal point. That means both of these zeros are significant. And we have 3, 4, 5 significant digits. Then we look at 804. Well, again, 8 and 4 are, but that 0, that zero's in the middle. Oh, it's a sandwich 0. So that means it's significant. So this time we have 3 significant digits. 960. Oh, it's one of those where it's at the end again. 9 and 6 are, but what about that 0? What are we looking for again? Oh, that's right. We're looking for the dot. The dot means a lot. The dot means a lot. Since there's no dot, there is no significance. So in this case, we only have 2 significant digits. And in the last one, well, 1 is significant. What about those zeros? What are we looking for? You got it, the dot. Oh, and we have 1. Since there is a dot in this number, all of my zeros are significant. So in this case, I have 3 significant digits. Don't worry, if you didn't get it yet, you will have lots of practice on this. Just ask anybody who's taken it before. We love Sig Digs. We usually just don't go around looking at a number and saying how many of these are significant. That really doesn't mean anything to us. So what we're going to look at is actually using it in math. And there are some rules then when we're using it in math. First way we're going to look at is addition and subtraction. So easiest thing, you're going to take whatever numbers you get and you're going to perform that calculation on your calculator. Hope you all brought a calculator with. You're supposed to. First thing you need to do is determine the lowest number of decimal places in all of your numbers involved in the equation. Number of decimal places tell us the precision of our number. So how precise we were able to get. So we're going to look at that least precise number, or the least number of decimal places. We don't have any decimal places, then we go back to our least precise number. So which number is the least precise? Once we determine that, we're going to take that answer that our calculator spit out at us, and we're going to round it to the lowest number of decimal places, or the lowest precise place value. For example, we do this number. We plug it into our calculator and the calculator spits out at us 8 points. So what does this number really mean? Not much. We have to look at our numbers. Which one is the least precise? Here we have 2 numbers in our decimal place. Here we have 1 and here we have 3. So which one is least precise? You got it, 6.4 with its 1 decimal place. We're gonna report our answer then with only 1 decimal place. So we're gonna report it as 8 points. So how we got there is we stopped that number there. We stopped it with just 1 place value, or 1 place after the decimal point if you like. Then we look, does 3 do anything to this 0? Will 3 round it up? No, it's too low. 3 does nothing. 3 does nothing. And our answer becomes 8.0. What if we're multiplying and dividing numbers? Well, our rules change just a little bit then. Still, we're going to perform the calculation. And then we're going to look at all of the numbers. But this time, we're going to look for the lowest number of significant digits. One of those reasons we have to know what numbers are significant. So we're going to look at which number has the lowest. And then again, we're going to round our number to have the lowest number of significant digits. So addition and subtraction, we're still doing the same steps. We're still looking for the lowest, but we're looking for precision. In multiplication and division, we're looking again for the lowest, but we're looking for lowest number of significant digits. So let's look at an example. We take 6.02 times 14.00 divided by 0.0030, and our calculator spits out that nice long number. Well, that's not the number we're going to report. So we're going to look at our lowest number of significant digits. In 6.02, we have 3 significant digits, and that's because that 0 is sandwiched between the 6 and the 2, so that one counts. In 14.00, we have 4 significant digits. It's at the end, but we have that 0, or we have that dot, sorry, and the dot means a lot. So we have 4 significant digits. In 0.0030, we have lots of zeros. Remember, zeros at the beginning don't count. But zeros at the end count if there's a dot. So is there a dot in this number? There sure is. We have one right at the beginning. So in this case, we have 2 significant digits. We are going to round our answer off so that we only have 2 significant digits. So we're going to report the answer as 28,000. Wow, what a difference. Look at all those numbers we chopped off. Well, if we look at this, we can only report 2 significant digits because that's the lowest number that I have. So we always start at the left hand side of the number. So there's our first significant digit. There's our second significant digit. So we cut it off there. 0 do nothing to 8. So we write down our number. However, if we had written, we would have been wrong. 28 does not equal 28,000. So we added, or we changed the rest of the number to zeros. And that's because we have to keep 8 in that thousandth place. If we don't, it changes the whole value of my answer. If you drop anything, so in this case we dropped all of these numbers, we have to change those to zeros. So anything we drop, we have to change to a 0, unless it's going to end up adding significant digits. So let's look at some practice. We take this number and we plug it into our calculator, and our calculator spits out the following answer. We look, ooh, we're multiplying, so that means I'm doing total sig digs. So how many sig digs in this number? Well, zero's at the end, but I have a dot, so yes, it is significant. That means I have 3 sig digs. In this number, I have a 0, but it's sandwiched, so this one is also significant. So in this case, I have 4 sig digs. So how many am I going to report in my answer? You got it. Lowest number, 3. 5 is significant because it's not 0. 9 is significant because it's not 0. And 8 is significant because it's not 0. There's 3 sig digs, so I'm going to drop my number. 8, we'll round 8 up. So I am going to report this answer as 59.9. I don't need to add these zeros, or I don't change these to 0, and that's because if I added them, I'd be adding significant digits, and we don't want that. We only want 3. In this case, we are adding. So when we are adding, we do it by decimal places. So I look at this, and how many decimal places? I have 4 decimal places. In this one, I have 3 decimal places. So which one is my least precise? It would be my 3. So that means I have to cut my answer so that I only have 3 places. So 1, 2, 3 places. Does 4 do anything to 7? No. So I would report this answer as 0.017. So you got to watch whether we are using significant digits, as in the multiplication, or whether we're using decimal places with the addition. So you can see I didn't even care about these zeros, whether they were significant or not. I wanted to know how many decimal places I was using. Where when we're looking at significant digits, we do care about those zeros. So let's try 2 more. This time I am subtracting. So if I'm subtracting, again, I'm going by number of decimal places. So in this answer, I have 3 decimal places. In this one, I have 2 decimal places. So my answer can only have, you got it, 2 decimal places. So does that count? No. Remember, I don't need to start counting there. I only need to count my decimal places. So there's 1, 2. I lop it off. Will 8 change 6? It sure will. So I get 7.17. Last one. I'm dividing. So I'm dividing, so this time I need to do sig digs. So I look at my first number. How many significant digits? There are 3 significant digits. In 300, Oh goodness, I have zeros again. Well, these zeros are at the end, so what am I looking for? Looking for a dot. I don't see any dot, so I guess these aren't significant. So this one, I only have one significant digit. All of this number means nothing. I just wasted my time writing it. That's okay. We're going to round it so that we only have one significant digit. So I start here. Oh, 0. Is that right? No, that zero's at the beginning, and those zeros are never significant. Do I need to write it? You betcha. But now I need to find one Sig Dig. 3. 3's not 0, so that's significant. Then we look, does 7 do anything to 3? It sure does. So I report this answer as 0.04. So I can check. I still only have one Sig Dig because 0 at the beginning is not significant. Do I write it? Of course. Because remember, 0.4 and 0.04 are not equal. So 0.4 is not correct. You need to write those zeros. So even though they're not significant, you still need to write them. Well, hope this has helped you understand significant digits a little bit. In a second, you're going to get a worksheet to have more practice with it. Remember, if you need to see me, stop by, let me know, and I can get you a pass to study hall so we can go over more significant digits. We will have some time in next class to work with it again. Well, hope you have a good day, and I hope you behave. See you next class.